Chapter 5 deals with solving systems of linear equations, and we have three different methods we can use. The first one we're looking at is the substitution method. We're also going to be looking at the elimination method and the use of matrices to solve these equations. And what a system of linear equations are is just two equations, and we want to find where their graphs intersect. There are three possibilities that you see on the screen. The first is when we have a unique solution. That's when we get exactly one answer. And that's when the graphs of our two linear equations intersect in exactly one point. The second type is when we can have infinitely many solutions. And this is when our two linear equations are exactly the same line. They lie on top of each other. And the third type is when you have no solution. And this happens when your two lines are parallel to each other. You see on the screen that these two parallel lines do not intersect, meaning that they do not have a solution. So the first method we're going to use in solving systems of equations is called the substitution method. And you've already seen how to find where two lines intersect, and we did that in Chapter 2 by solving each equation for y, and then we set the two equations equal to each other and solve for x. You can still use that method, but I'm showing you a slightly different approach to this called the substitution method. The substitution method is when you solve one equation for a variable, and then you substitute that equation into the variable in the other equation, and then solve for the remaining variable. So beginning with our example, 3x plus y equal 1 and negative x plus 2y equal 9. We want to solve this system of equations. So the first thing I'm going to do is I'm going to solve my first equation for y, because that's just the easier variable to solve for. It doesn't matter if you're solving for y or x. I'm solving for y in this case because the coefficient of y is equal to 1. So that's going to make it easier to solve. So what I would need to do is subtract 3x from both sides, leaving me with y equal negative 3x plus 1. And now I'm going to take what y is equal to, negative 3x plus 1, and substitute it into my second equation. And when I substitute, this will give me negative x plus 2 times negative 3x plus 1. Equal to 9. And now we're back down to just a simple linear equation solving for x. So we can distribute the 2 that's on the outside of the parentheses. That would give us negative x minus 6x plus 2 equal to 9. And now we combine like terms and get the x on one side by itself by subtracting 2 from both sides. And then dividing by negative 7 tells us that x equals negative 1. Now, our solution for any system of linear equations needs to be as an ordered pair. You need to have the x and the y value. So we take our x equal negative 1, substitute it back into either equation. It does not matter which one. I'm going to use the second one because it looks like it might be a little easier to solve for. So negative 1 substituting in gives us a positive 1 plus 2y equals 9. Subtracting 1 from both sides gives us 2y equals 8. When we divide by 2, we get y equal 4. So our final answer is negative 1, 4. This is where our two equations will intersect each other.